Okay, in this video I'm going to attempt to show you a piecewise function. And all this means, this one's really complicated for a lot of people, but it doesn't have to be. This could be the easiest thing you've ever done. You just have to see the patterns and see what represents certain features on the graph. Now I know it looks complicated because there's more than one piece, but we're going to take this little by little. Okay, it's basically two functions on the same graph that are split up so that one of them exists on one side of a boundary and one exists on the other side. What we're going to look at first is our boundary. Okay, what you see in orange right here, that has a meaning, and that's where this graph gets split up. Okay. So what I would like to do is draw a dotted line at that boundary, just to mark it so we know where it's at. Okay, this is at x. We can see something is happening at -1 for the x coordinate. So I'm going to go to my x axis, and I'm going to go over to -1, and I'm going to draw a little boundary right there. Okay, something's happening here. I'm not sure what, but something. Okay, something's going to get broken up right there. Okay, now let's go back and look at our functions. Let's start with the green one. Okay, the green one says y equals 3. I know that doesn't look like a function, but it is. It's a constant function. It means y is always 3. Okay, so I'm going to draw that in, and I'm going to ignore the orange just for a minute. 1, 2, 3. Okay. There's y equals 3. Now let's go down to the red one and do the same thing. Y equals 2x plus 1. I'm going to draw that function in. I'm going to start at +1. I'm going to go up 2 over 1. So I get a function that looks like this. Y equals 2x plus 1. Now, the definition of a function is it can't have more than one point, more than one y coordinate for every x coordinate. Okay, so there can't be more than one output for every input. We can't have two functions existing in the same spot. Remember the vertical line test. So what we need to do is be able to read this graph left to right, okay, reading this direction, and at any given time only have one function there. Now, to put this into simple terms, back to the orange. Let's look up here. The green function only exists for x values that are bigger than -1. Well, which side of this orange is bigger than -1? Well, it would be on this side. Okay, this side, the right side, is the positive side. It's bigger than -1. So that means this is going to be hard to do. I'll see if I can make this work. That means my green function can only exist for numbers bigger than -1 on the x-axis, so it can't exist over here. Now, likewise, my red function, over here, my red function can only exist for numbers less than -1, which would be on this side of the boundary. So that means that my red function cannot exist right here. Okay, now I just messed this up a little bit, but I can go back and fix it. Green, red, and the last clue is what happens at the boundary. Which one of these functions exists right on the boundary? And I can see right there that the red function has the equal to portion. So I'm going to put a big dot colored in right here, and on the green, I'm going to put an open dot. And notice now as I go left to right on this graph, okay, I've got the red function happening, the red function happening, the red function's going, and then all of a sudden it stops at the boundary, boom, and it switches to the green function. Okay. And those dotted lines aren't really part of the graph. I was just showing you how this follows along. But that's a piecewise function. Basically, you need to do two separate graphs, and then cut half of one off and half of another one off, and you're done.